So in our next section, section 7.6, we are going to be looking at trigonometric equations. And in order to take a look at trigonometric equations, let's revisit some of the other techniques we used for solving equations. First, we said just solve them if they're basic enough. For example, if we had x plus 2 is equal to 0, we don't have to use any crazy techniques. You just bring the 2 over and get the answer. The most important thing in math is factoring. So we are going to be factoring in this section. And when we factor, we have just regular GCF factoring. We have grouping. Probably one of the main factoring techniques is when we are dealing with trinomials. Specifically, in trig equations, we might have to use quadratic techniques, but we'll talk about that when we get there. And we also have special cases. Now with regular equations, we also had the rational root theorem, we had the location principle. We're not going to need to do any of that kind of stuff here, but let's get into some problems. First, let's take a look at what some basic trig equations would look like. And the directions are going to be to solve in the interval from 0 degrees to 360 degrees. We're not going to include 360 because that's the same as 0. So let's start with the sine of x plus 2 is equal to 3. Now the directions are between 0 degrees and 360. Sometimes the answer is in radians, sometimes it's in degrees. If we put an x, that typically means radians. So let's get an answer here, and we will answer in degrees or radians. First, we could just bring the 2 over. Now, when is sine 1? Well, sine is 1 using the quadrantal angles right here at 90 degrees. So x would be 90 degrees, or if we were going to write our answer in radians, we would use pi over 2. What about if we had a problem like this, where 2 secant of x plus 1 is equal to secant of x plus 3? Well, if we want to solve for x, let's get all the x's on the same side by subtracting a secant on both sides. 2 secant minus 1 secant is just secant. And let's bring the 1 over also. So when is secant 2? Or that's the same thing as asking when is cosine 1 over 2? Well, that came from our 30, 60, 90 triangles. And cosine of 60 degrees would give us 1 over 2. But we know that if all students take calculus, we could also draw our 60 degrees right here. And cosine would also give us a triangle right there. So our answer could be 60 degrees and 300 degrees. Or if we were going to write our answer in radians, it would be pi over 3, and 300 would be 5 times that, so 5 pi over 3. Take a look at one more basic kind of problem. What if the problem was the cosecant squared of x plus 2 is equal to 1? So let's bring the 2 on the other side, the square root. We get the absolute value of cosecant of x is equal to I. Remember, the square root of -1 is I, and I squared is -1. So we're looking to see when is cosecant plus or minus I, or when is the sine of x equal to 1 over plus or minus I. And that's kind of a bizarre question because we know sine only goes between 1 and -1. So trig functions will never be imaginary. So we'll just say that there's no solution for this problem. Let's move on to problems where we have to factor. And the directions for this is we're actually going to be solving for all values, not just between 0 and 360. When you hear all values, what that means is whatever answer you get, we always add the period to the answer. And we'll see that when we go through these problems. But let's say you get, for sine, you get an answer of 30 degrees. You would put 30 degrees plus the period, because every 360 degrees you would get the same exact answer. So let's take a look. What if we had a problem like this, where it was the cosecant of x plus 2 times the cosecant of x minus the square root of 2 is equal to 0. Well, because we're factoring, we could use the zero product property and set each of these equal to 0. Now, if cosecant of x is -2, another way to think about this, remember that's the reciprocal of sine. So sine would be -1 over 2. And that happens. We wouldn't draw it in this quadrant where sine is positive. Sine of 30 degrees would give us 1/2. But we want to draw the 30 degrees where sine would be negative, which would be this angle, which is 180 plus 30, and this angle, which is almost a full circle, but 30 degrees short. And because we're looking for all the values, we would write plus 360k. What the k means is just how many periods are you looking to go past. So it's not really a big deal. We're adding the period just to say that we would get -1/2 at 210, or 210 plus 360, or 210 plus 2 times 360. That's what that means. If you're looking for all values, you write plus the period. Now let's do this other piece. Cosecant of x minus root 2 is equal to 0. Bring the root 2 on the other side. So another way to say this is, when is the sine of x 1 over root 2? And that happens at 45 degrees. So let's see if we could figure out all the values. Sine would be positive in these two quadrants. So if we draw our 45-degree reference angle here, our answer for the second piece would be 45 degrees plus the period of sine, and 180 minus 45, or 135 degrees plus the period of sine. So our answer would be all 4 of these. Let's try another one. How about something like this? If the tangent of theta times the sine of theta minus root 3 sine of theta is equal to 0, we could easily take out a GCF of sine of theta, and we get tan theta minus root 3. Setting these factors equal to 0, well, when is sine 0? That happens along the quadrantal angle right here. Sine would be 1. Remember, sine's the y value. So sine would be 0 right here, and right here. So theta would equal 0 degrees plus the period, okay, and 180 degrees plus the period times k. Let's look at this other piece. When would tangent of theta minus root 3 equal 0? Well, we could bring the root 3 on the other side. And we get a tangent of root 3 from our 30, 60, 90 triangle. 1, 2, and root 3. The tangent of 60 degrees would give us root 3. So I'm going to draw 60 degrees in the quadrants where tangent is positive. Tangent's positive in the first and the third quadrants. So my answer would be 60 degrees, but also this one right here, 180 plus the 60 is 240. Now just be careful, what's the period of tangent? It's 180, right? So technically we don't even have to write the 240 because 60 degrees plus 180 is 240. Generally I do, it's redundant, but the technically correct answers would be this. 60 degrees plus 180 is 240. So we don't have to include that, it's just redundant to do that, but that's where it comes from. It would be 60 plus 180, and 240 you could also get by drawing the triangle here. And we'll finish talking about some trinomials and some more advanced equations. So we had a problem like this. Cosine squared of x minus 2 cosine of x plus 1 is equal to 0. And we'll look for all our values here. Meaning we'll just add the period at the end. So this is clearly a trinomial. Let's use quadratic techniques. And what that means is we'll make a substitution where this middle term gets substituted for y. So we could write, I'll show you why this works, and then we'll actually do it. Cosine of x, cosine of x. If we substitute y in for cosine, we could factor this and solve. So y would equal 1, and of course it's the same thing on the other side. But remember, we said y was cosine. So really, when is cosine equal to 1? It's the same thing over here. You don't have to write it twice, but well, cosine would be 1 when the x value is 1, which is right here on our quadrantal angles. That would happen at 0 degrees or 360. And because we're looking for all the values, we could write 0 degrees plus the period. Let's do a couple more. What about if we had 3 times the sine squared of theta minus the sine of theta is equal to 2? Now when we're solving advanced equations, generally we have it always equal to 0, and then we work from there. So I'll bring the 2 on the other side, and I think we're going to have to be using quadratic techniques again for this. So we'll substitute y in for sine, and then we'll factor this like we usually do. What are some factors of -6 that add up to -1? Well, -3 and 2 would get our job done. So this would turn into 3y squared minus 3y plus 2y minus 2. We can cut down the middle, take out a 3. We could take out a 2. And we get y minus 1 times 3y plus 2. and solving for y, we'd get y is 1, and if we subtract 2, we get y is equal to negative 2/3. Remember, y was sine, so you can't just stop here. Let's finish the problem. So when is sine 1, and when is sine negative 2/3? Well, sine is 1 on our quadrantal angles when the y value is 1, which is right here. That was at 90 degrees. So we're going to write 90 degrees plus the period of sine. But for this one, it's a little bit trickier because we don't have a special triangle that gives us just regular 2 and 3. So let's talk about how to use the inverse sine function on our calculator. If we want to get rid of sine, what we could do is we could take the inverse of both sides. Make sure your calculator's in degree mode. Inverse sine and sine would cancel. And if you type into your calculator the inverse sine of negative 2/3, my calculators give me an answer of negative 41.8 degrees, which is right here. Now that should make sense because in that quadrant, sine is totally negative, right? Sine would be negative in the 4th quadrant and in our 3rd quadrant. So one of the answers is negative 41.8 degrees plus the period of sine. The way we get the other answer is we draw that reference angle in the 3rd quadrant, 41.8. This angle would be 180 plus 41.8, which is 221.8 degrees, plus the period. So this was a little bit new for us. We had to use the inverse button. Usually we do this stuff in our head, but that's how you would solve for an angle that's not from a special triangle or a quadrantal angle. So the 3 answers for this problem would be what I just circled here. We'll do one more. What if we had the secant squared of theta is equal to 2 tangent of theta plus 4? So let's get everything on the same side. Secant squared of theta minus 2 tangent of theta minus 4 is equal to 0. And this is where it gets a little tricky because we have different trig functions. But we do have a Pythagorean identity. The Pythagorean identity said that secant squared, or it said, remember, sine squared of theta plus cosine squared of theta is 1. That's the one that I always remember, and I asked you guys to remember that too. If we want to get secant, we're going to have to divide everything by cosine squared. And this gives us tangent squared of theta plus 1 is equal to our secant squared of theta. So let's actually use that property. Instead of secant squared, let's replace it with tangent, so we have all the same trig functions. This is going to be the tangent squared of theta plus 1 minus 2 tangent theta minus 4 is equal to 0. Combine our like terms. Use quadratic techniques where we substitute tangent in for y. And we could factor this. This would be y and y, 3 and 1. So we get y minus 3 is equal to 0, or y is equal to 3. y plus 1 is equal to 0, or y is equal to negative 1. But remember, we said that y was tangent, right? So don't get too excited here. We have to finish the problem. Okay, so when is tangent 3? Well, that's not a special angle. So we're going to have to use inverse on our calculator. The inverse tangent of theta would cancel these out, but we would also have to take the inverse tangent of 3. So if we type that into our calculator, the inverse tangent of 3 is 71.6 degrees. We'll add the period. 71.6 puts us right here, which makes sense. We're supposed to get a positive 3. We get a positive 3 there. And if all students take calculus, tangent would also be positive right here. This angle is 180 plus the 71.6, which is 251.6 degrees. We would add the period. We don't have to actually include that here because 71.6 plus 180 gives us that angle anyway, so you don't have to repeat that. It's redundant. Let's finish this by dealing with the other side. So when is tangent negative 1? Well, I know tangent is 1 at 45 degrees, so we get 1 over 2. So tangent of 45 is 1, but we want to get negative 1. So let's draw 45 degrees in the quadrants where tangent's negative. Wouldn't it be negative here or here? We would get a negative tangent in this quadrant and in this quadrant. This angle is 135 degrees plus the period of tangent. This angle is 360 minus 45, or 315, plus the period of tangent. We don't have to actually include 315 because that's 135 plus the 180. Now you can include these if you want. I'm not going to mark them wrong. But as far as the best answer, the most concise answer would be 71.6 plus 180k and 135 degrees plus 180k. Thank you for your attention. Please stay tuned for our next section.